Hi, my name is Mike Bonham. I am the Global Head of IT Networks for Syngenta. I'm joined here by Sujay Murphy, the NSO Applications team, and we're going to talk about the success that we have with NSO and SAE at Syngenta. Syngenta is a leader in innovation globally for renewable sources and smart farming. We have operations in over 100 countries. We've recently merged with a couple of other groups to form Syngenta Group, which is now operating again in 100 countries with over 60,000 users. I personally manage 450 locations within that, and my population base is 65,000. We are trying to transform the way that we connect to the rest of the world. So we have a large presence in AWS and Azure today. We are in the process of migrating more of that and also trying to get some SD-WAN deployments out so that we can have a little more control over the network. We're moving away from MPLS network by a managed provider and trying to build something that is a little more us, a little more control, a little more flexibility, a lot less cost in the process. We're also trying to get a internet-centric implementation. Right now, what we have is each individual site basically has its own security mechanisms. It has its own internet connectivity. They do have MPLS, but they also have internet. And so we're trying to change that and change the ways that we can connect with those things to get away from the MPLS control of those. We also wanted to be able to centralize the security stack. So by going with a colocation provider, we can put something in the middle that we have more control over and can centralize the traffic. So it's turning into a bit of a hub and spoke type model where we are funneling all the traffic back through a centralized point where it makes sense, and then others, there's local breakout, but we are able to inspect the traffic that we want. So certain traffic, we would never inspect, healthcare, HIPAA stuff, anything that's protected that we would not want to inspect, but everything else gets funneled through our centralized security mechanisms. We needed a way to support that. And the last challenge that we have is around our ever-changing business needs. So we have, again, just formed Syngenta Group where my user base effectively doubled. And so I have a logical architecture that really supports that, and we can adapt that fairly frequently. But I needed a physical stack that could do the exact same thing. For design criteria, we were looking at performance hubs. Performance hubs are the centralized points where we deploy this particular technology. We, again, really wanted to centralize on the security. We didn't have enough consistency. We didn't have enough transparency. We used some online as a service type security appliances to give us some view of that. It was both expensive. There was problems with connectivity, those types of issues. So we wanted to really have a lot more control in here. We also wanted to be able to introduce some choke points within the network. So getting from site to site, getting from the sites to AWS or Azure or anywhere else, we needed to be able to adapt to that. Again, we were just Syngenta as well, and now Syngenta Group. We added our COVID situation here, and our needs keep changing. So we needed something very adaptable, and we also wanted to future-proof a bit. We knew it was changing. We just didn't know what it was changing to. And so the challenge is how do we build a network and drive down our costs while changing the entire structure and then needing it to change as we're going, which was a big challenge. We needed a modular design as well. So we have certain components of our network that are not fully live just yet. So for example, we have a managed service that does the MVPN for us to manage a certain number of our sites. We needed to be able to add that, but we didn't need it right now. And so what we were able to do modularly is build different service chains and such that that could adapt to that need as it came up instead of having to have everything all at once. SAE. So the right solution for us is around the virtualization. So this is really what it came down to. The virtualization was one of the biggest drivers here. We considered a very physical stack, a set of security appliances, a set of routers and switches, and of various types and sizes of all that. But the one thing we didn't know, again, was what was the right solution as we're continually changing. So we have, again, doubled our size, and in such, We have not, under the virtualization platform, needed to double the architecture, whereas I'm not sure that would have been the case if we would have gone the physical. We are also now to have a different conversation. So previously, we were having design architecture discussions around what does the physical design look like. The physical design was preventing certain things. How do we wire it? Where do we put it? Is there enough rack space? All of that. Now what we have is conversations with what do we want the network to do? So it's a little bit different conversations. We're also able to completely rebuild it fairly constantly, which is super useful. It is also enabling our third-party support. So rather than having to deal with third-party providers for all the hardware components, I can now virtualize those as well, and I have the platform that's consistent between all of them. So I've got Cisco, I've got other third parties for security, for DDI, for monitoring, automation, scripting type things right there in our performance hubs, and I'm able to co-locate those at each performance hub without, again, expanding into needing more racks or more space or even send someone to the site. And then the future proofing of this, again, is I'm able to currently go through and completely redesign the network using the exact same solution. And so we've multiple times now redesigned the entire service chain structure or added a new service chain. The conversations we have today is like, hey, couldn't we add a new service chain to do this next week? And the answer is, yeah, we could. And we do that semi-frequently now. Our smart hubs, these are the points of presence that we have throughout the world. So we're, again, 100 countries, so we needed a presence all over. What we have is basically pairs of hubs that we put in these locations. Part of the goal is to put them in locations that are within a certain amount of latency of most of our sites. It doesn't cover Africa very well, but there are some exceptions there. But other than that, most of these locations will service the vast majority of sites in under 10 or 15 milliseconds access directly to them. We chose these specific locations because these are the internet exchange points as well. And so what we're doing is putting the internet exchange is where we put our colo, so the edge of our network actually goes right up to the edge of the internet. So now if I want to get to AWS, it's a cross connect as opposed to going through an MPLS provider or having to go through some other mechanism to actually get to AWS. Now I'm almost directly on it. Adoption challenges. The biggest one we had to start was around the mindset. I cannot stress this one enough. This was a huge undertaking, especially at the very beginning. We approached this problem like traditional networks and traditional network people would. We had a slew of CCIEs, we had partners from Cisco, we had people on my team, we had lots of people looking at it, and everybody said it was really hard. And so I joined after the initial project had kicked off, but I had a lot of background in this because I had implemented it elsewhere. And so the thing that we found that works really well is changing this from a networking concept into a infrastructure or DevOps type concept. And so we need different people. We need automation people. I can't stress that enough. You can't live with just CCIEs alone. You need someone that can automate. You need someone that is used to administering systems. That's one of the biggest challenges that we've had. Since doing that, we've made vast improvements, and it's just a different approach. So we now look at the solution as infrastructure as a code, or basically a mini cloud that we can administer in each one of these locations. So we can now automate it. We can use any varying numbers of automation, but we also have to introduce new things like Git and Ansible and Chef and Puppet, which are not typically used in your average router configuration. Some use, but this is much more significant. There are hundreds of files that we manage currently, the templates for each individual hub. And then again, we have anywhere from 10 to 13 hubs. So it's quite a large number of files to maintain and keep that going. We also found that maintaining compatibility was not necessarily a challenge just yet, but it is an ongoing challenge that will happen. That compatibility is really around the third-party applications. So I've got security appliances, I have monitoring, I have scripting, I have automation. Security is probably the biggest concern. I haven't had a problem yet, but it is a risk that is there. Whether or not that particular security appliance is certified to work underneath the SAE platform. There has been an instance where, we asked Cisco, hey, are you up ready for this version? And the answer is we haven't tested it yet. But again, it's working. It's typical virtualization type stuff. It should be fine. The challenge really is around the security again, because they release so frequently that trying to maintain compatibility can sometimes be hard. So now to talk about the more technical details of this, I will hand it off to Sujay.
Thanks, Mike, for the wonderful overview. So, hello, folks. This is Sujay here from the NSO application team at Cisco. I will cover some of the aspects of the Syngenta hub design that we had to go through, considering the network challenges and the requirements of Syngenta to really make this as a co-location offering and a service. So, after the discussion with the Syngenta teams, I think we at Cisco and the Syngenta had to collaborate together to really understand what are their SAE hub service chain requirements. How are they looking at the connectivity between their DMVPN, fiber VPLS or MPLS sessions towards their applications going towards cloud on AWS or Azure, and then also looking at their other connectivity requirements from VPN, IPsec, or the ingress traffic that would terminate at their sites, and then how SAE service chains should be designed considering their requirements towards the traffic going between intersite as well as the data center interconnect between the services. So this donut size a picture really replicates what the consumer zones are and how we distinguish between the consumer zone traffic going towards the provider zone traffic, and what are the various VNF type requirements. If you see, they have requirements right from Palo Alto VMs to, like we have the Cisco CSR, or also ASAV doing the RAVPN stuff, and also bringing in the virtualization along with the physical infrastructure, that is the Meraki MX450 connecting to one of the hub sites. So once we've designed this, right, the challenges were always to define what are your service chains, how would you implement them, or how would you design using the SAE UI or the SAE core function pack running on NSO services. So the traffic ingress for SD-WAN, VPLS, and then from your Megaport towards for AWS, Azure service chains, and also then using your shared services, which is using ICE internet connectivity to data center interconnect, and finally the out-of-band management. So what are the building blocks for SAE, right? I mean, after all the design, there is always, we wanted to maximize what Syngenta's requirements were, meet the needs for the design and the building blocks. So CSP as an NFV platform that is used to showcase, that is a performance-focused hardware which can spin up to any third-party VNFs. There are certified Cisco and third-party VNFs that is focused for the CSP platform. Then on the flexible switching fabric, that is the Nexus 9K switches, which are VNF-ready fabric, which can scale for small and large deployments. And then finally on the orchestration, using the NSO ESC and the Etsimano stack using for the VNF virtualization to create the models for service chain deployments. That is, the motto is you design once and you redeploy those service chains multiple times, or as the needs are changing, or you have the VNF definitions to be defined and all orchestrated using the SAE core function pack services. With virtualization as a key part or the key component to the requirements, CSP was definitely the right choice on the platform because it can scale up. You can add more cores or more CPUs to your VNFs. You can define your VNF flavors to say whether you want a small, medium, or a large flavor. And then you can scale your addition of more VNFs or increasing the type of the VNF. Finally, also looking towards the right on the scale out, that is on the scale out options, where you can scale to more number of service chains. So as the demand grows, if the hardware requirements are there, the hardware resources are available to bring in more service chains, more service engines, perform more transitions towards service chain for co-locations. That is where CSP would really be a fit on this part. And finally, on the scale down, I mean, you can scale down as your operations because the orchestration stack can really help you to leverage this on addition of flavors or modifying your flavors for the service chain deployments. And finally, the centralized API management using the nets, which was really helpful for any day one operations that is needed for any customization on the service chain VNFs between the Nexus 9 key switches or the physical hardware stack that is added as part of the service. So service chain sizing, right? This was the key component to understand. Like every service chain requirements had a different bandwidth usage, different links, the number of links to the VNFs, and the different type of flavors. So the resource management or the resource orchestration in the NSO was really a key component to make those placement decisions. Like how would you place a service chains which are having so many constraints? Like if there are 4 CSPs that was designed for the site and there are multiple constraints needed between your shared services and your AWS, you had your resource zoning aspect that can cater to these requirements for the services. So this is a small snippet of the service chains, but I will now switch over to the hub demo where we have a replica of the Syngenta service chain in our lab. So let me switch panes here. Right. So this is a single site deployment for Syngenta that we have a replica, but the SAE solution GUI really helps to facilitate this orchestration and deployments. It's a single portal available to view your multiple sites, look at the multiple deployments, and if there are any errors, this is a single view pane for the site. So we will go through one of the site here as the deployments, right? So this is a whole circular concept of all the chains that we have connected. If you see that we have 104 stitching services, and that's what Mike mentioned, like they wanted to do something that they could do like when there are demands, when there are increasing needs and requirements, they could stitch service chains or spin up new service chains as intended. So we really look at like for every site deployments, you can look like, okay, what are the site connectivity to each of the hubs? Or where does like, for example, my Meraki chain is connected to these deployments. And also I can look at the each service chain. So fiber service chain, what is the configuration, the number of links that are connected to them, and where are they deployed with, what are the resources, what are the IP addresses, the VLANs, the BGP AS pools, defined for each of the service chains. So the GUI is actually helpful in looking at this site deployments, looking at the connections. Also, if I want to look between AZ and Azure and Internet, what are my connections between them? These are the 2 endpoint gateways which are connected from their connections. And this will show me the link between the stitching services to say what is between the consumer VRF and the provider VRF that the routes are being propagated. So clearly a list view, we can also look at the list view of all the endpoints here on the endpoint ASN, IP address, netmask, VLAN for each of the endpoints that are connected. All right, so that is basically what we have on the design. And then on the service design, we can create the service chain that is using HC Stack for NFV. So we have all the NSD service chains designed here for these deployments. So this is a replica of one of the site deployments that we have, and now I'll pass this back to Mike.
Thank you, Sujay. So benefits. We did this. What did we get out of it? The very first thing is something Sujay mentioned, which was design once, deploy multiple times. So we've got these service chains. We've got a number of them. We keep adding them. As we add them, we don't have to go manually create everything. So we do have service chains where we create it. We have to put some variables into it, but that's part of what the orchestration is able to provide. And so we're able to deploy a new service chain across 10 hubs fairly easily at this point. And so it's a reusable design, which is pretty helpful. We're also able to do the incremental deployments, as he mentioned. As we started out, we didn't need a DMVP and service chain. We didn't need a service chain for this particular type of site or type of connectivity. We didn't need a service chain to connect to an Oracle Cloud or something like that. It really didn't matter what it was. We were able to add those things incrementally, which is pretty helpful. It also gave us the donut itself, the structure of the donut, gave us a bit of network access control. And so it was the ability to segment off a portion of the network, both for security needs as well as just general operational needs as they came up. The COVID situation has also introduced a new twist in this, which is the colos are somewhat difficult sometimes to work with. So getting into the colos can be problematic. We've had some issues with doing that, just in deploying new hardware. But with this functionality, I'm actually now able to completely redeploy the entire thing, other than physical, completely remotely. I don't have to send someone to the colo to move something around or introduce a new switch or introduce a new workflow. That's the advantage of moving away from the physical into the virtual now. So that's been pretty significant, specifically here in times of COVID. We also use a lot of automation. So we use Ansible, Python, Perl, Chef, Puppet, Git, you name it. There's a lot of things that you're going to find that are much more system administration type things, specifically in Linux systems. And those are skills that you're going to want. Again, if you put only CCIEs on this, it's difficult. But now with the benefits is now I can bring multiples of those teams together, and combining the CCIE with the automation person and the monitoring person, I'm getting more benefits than whenever I had it in physical and having it separate. And the last one is around our failover management. So we have some level of resiliency within a hub, but the automation orchestration components of this now also allow us to drive the hubs themselves. So again, from the map earlier, there are pairs of hubs that are going, and those are primary failovers within a particular region or for a specific purpose. And so take Chicago and Ashburn, for example. The locations that are primarily closer to Chicago connect through Chicago, and the ones that are closer to Ashburn connect through Ashburn. But we can programmatically force everything through one side or the other, and we do that for maintenance, upgrades, any kind of incident that we have, anything like that. So the failover management capabilities are actually pretty significant as well. We can also use the capacity on demand type things and be able to get more capacity out of the existing system by spinning up additional resources. So it's pretty flexible from that standpoint. I want to call out the team that was able to accomplish this. So the first one is Ka. Ka is our consultant that came in. He had the initial vision for the design of the network itself. He and I have worked on this at previous companies as well. So it's a good design. And then we look at the Cisco team that really drove this. I don't think we would be anywhere without them, obviously. Being a little on the forefront of the technology, it was super cool to have a partnership that we have to make that happen. And then we have E+, who is our primary implementation partner. They helped us design it, spent many months trying to work out the kinks, both in our design and implementation, but also got some of the challenges of automation versus configuration and trying to figure it out. And then the last one is SecureOps, who is our current implementation and operations partner, who is really focused on keeping the hubs up and running and doing all the day-to-day maintenance. And they're also implementing additional service chains as required. And again, they've only been doing it for a couple of months now, and in the process, I'll go to them and say, hey, I need a new service chain that does this. Like, okay. And so in fairly short order, we're able to stand those types of things up. Again, appreciate all of the help from Cisco and the partners that we had in place. Also, thank you all for joining us and experiencing Syngenta's journey through implementation of SAE.